So let's pick up where we left off yesterday and review a little bit. We talked about parent functions and then the fact that we can change all parent functions to a different form that will kind of fit this equation right here. Each of these has a specific task in the function. The h value will move to the left and the right every single point. K value moves up and down every single point. A value acts as a multiplier for the y values of the parent function, and the b value acts as an x multiplier for the parent function. So those can change the actual shape of the parent function graph. And like we said yesterday, we took and just translated graphs left and right. Today we're going to do a little bit more than that. So as we did yesterday, let's first of all identify the four values of a, b, h, and k. A is that number that multiplies things out in front. So you'll see that a in this case is a value of -2. B is within the function itself and represented as either a multiplier in front of the variable or a division of the term. Again, we have to make sure we have a coefficient of 1 in front of the x, so that in this case b is 1. H follows a subtraction sign within the function, so h is -6, and k is that addition or subtracted number, so k is equal to 3. So then we identify our parent function. In this case it's root x. We take a look at the pattern of that parent function, which is 0, 0, 1, 1, 4, 2. We can go to 9, 3. And then we are also going to notice that we did have an a value, so that's a y multiplier. So in this case, we're going to multiply all values of y by a -2. So that's a 0, -2, -4, and -6. And now let's see what happens in the graph. So with my h and k, I'm going to go back 6, and I'm going to go up 3. I'm going to put the crosshairs and plot the origin point of 0, 0. Then here are my x movements. Here are my new y movements. So I'm going to go over 1 but down 2. I'm going to go over 4 and down 4. And then I'm going to go over 9 and down 6. And so this is a picture of what my graph would look like. Let's see how that goes through there. And again, we said don't walk away unless you check the point. So I'm going to check this point -2, -1, and make sure it works in this function. So let's put a -1 in for y. So I have -2 root -2 plus 6 plus 3. Got -2 root 4 plus 3. That's 2 times -2, -4 plus 3. That better equal -1, and it does. So that looks to be correct. In our next problem, we're going to take and graph this function. We note that outside the function there's no multiplier, so our y value is an a. We have a coefficient of 1 in front of the x, so we're all good to go there. Below, within the function, is a division of 2, so that's got to be our b value. H value, it follows the negative sign, so that's 5. K value is the -2. So again, I'm going to take and go over 5, and I'm going to go down 2, put some crosshairs, marking that translated point. I'm going to identify the function as an x cubed function, and I'm going to write out the pattern for that. So we're going to go 2, 8, 1, 1, 0, 0, -1, -1, and -2, -8. And then since this has a b in it, that's an x multiplier. I'm going to take all my x values and multiply those by 2. So I have a 4, a 2, a 0, a -2, and a -4. And then I'm going to graph those x and y movements from that translated origin. So I move over 4 and up 8. 1, 2, 3, 4, 6, 7, 8. Like so. Move over 2 and up 1. Still got a 0, 0. Back 2, down 1, and back 4, down 8. Let's see, 2-ish, right around here. And then I draw my graph from there. I'll use the point, what is that, 7 and -1 to check. Pop it in right here. -1 equals 7 minus 5 over 2 cubed minus 2. 7 minus 5 is 2 over 2 is 1 cubed minus 2, which is 1 minus 2, which is -1. Check, and I'm good to go. So now we have a situation where the a value is 1. I'm unsure of what to do next because this isn't in a proper form. What I need to do is make sure that coefficient of x has a 1 in front of it. So let's first of all go ahead and factor. Pull a 2 out and we have x plus 6. And then I need to make sure my b value is represented by a fraction, which it doesn't in this case. So y is equal to square root of x plus 6, let's make that square root bigger, over a half, because dividing by a half is the same as multiplying by 2. So now I can define everything I need to. B in this case is a half, h is a -6, and k is 0. So now I'm going to move over -6, put a dot in a crosshair. My parent function's root x. Done that one before. So I have 0, 1, 4, 9 and 0, 1, 2, 3 for my x and y's. I have a x multiplier of a half. So it's 0, a half, 2, and 9 halves. So now I'll graph that from here. I move over a half and I move up 1. I move over 2 and up 2. Then I move over 4 and a half. So 1, 2, 3, 4 and a half, and up 3. Sketch my graph, but don't forget to pick a point. This is -4 and 2. Plug that in, make sure it works. So here's a 2 equals square root 2 times -4 plus 12. -8 plus 12 is 4. Square root of 4 is equal to 2, and I'm checked off again. So in this problem, again, we've got an issue where we don't have the correct form of the problem because this term does not have a coefficient of 1. So let's fix that. Make that -2, 1/3 x plus 6 squared plus 8. Clean that up. That's -2 x plus 6 over 3 squared plus 8 equals y. So now I know a is going to be -2, b is going to be 3, h -6, k 8, parent function x squared. We've got x and y of 0, 0, 1, 1, 2, 4, 3, 9. I I have both x and y multipliers in this case. Y multiplier of -2. X multiplier of 3, so that's 0, 3, 6, and 9. And 0, -2, -8, and -18. That's a big one. All right. I don't know if I'm going to do this last guy. But anyways, let's go translate 6 back and 8 up. Put my crosshairs there and put my dot. For 0, 0, go over 3, 1, 2, 3, down 2, 1, 2, in both directions. 1, 2, 3, 1, 2. And then let's go over 6 and down 8, which puts me here. Over 6, 2, 3, down 8, which puts me here. All right. I could do the other point if I wanted. I think I've got room, but I'm just going to leave it at this. Like so. Don't want to walk away again. So let's use this point 0, 0. That's usually an easy one to check. So I have -2 times 1/3 times 0 plus 2 squared plus 8 better equals 0. This is -2 times 2 squared plus 8, which is 4, -8 plus 8, which is 0, check. All right, so we've graphed pretty much everything we need to graph. Now we're going to take and go the other way. So here's a graph, and we want to write the equation. And I'm telling you that this comes from a parent function of x squared. So something has happened to this. And we can clearly see the vertex is up here. I think the easiest way to do this is put it in this form. Y equals a x minus h squared plus k. Now, you'll notice I've excluded the b value, and I've done that purposely because if you really think about it, if I were to take our normal, function and say, let's say I had a b in here and no a, and that b happened to be a 2. Well, if I square that 2, there's a 4 now in the denominator, and I can factor out a 4. So doing an x multiplier of 4 is the same as a y multiplier of a quarter. So really a horizontal compression or stretch also acts similarly, but in a vertical way. All right, it's kind of the reciprocal, if you will, of the vertical. So I'm just going to say let's do just a vertical, because any vertical can be expressed as a horizontal or a combination of the two. So here we go. I know HK at this point is 0, 6. So I'm going to shove that in. I've got y equals a x minus 0 squared plus 6. Now I'll clean that up. Y equals a x squared plus 6. Now, all I really need to do is find my a value. But the only way to do that is if I know an x and a y. Well, I got plenty of them to pick from over here. Let's just use 2, 2. Put a 2 for the y, a here, 2 for the x, square it, add 6 to it. I'm going to bring the 6 over, giving me a -4. This value right here is a 4a, so a equals -1. Therefore, the equation is y equals -1 times x squared plus 6. And I'm done. Do it again for a different function. This time it's a q root function. And again, this central value or the symmetry value right here is 4, 2, so that's my h and my k. So again, I will go y equals a q roots of x minus 4 plus 2, but I'm going to need to find that a value. So I'm going to use an x and a y. Let's use this one. I have a y value of a half equals unknown a cube roots. The x value is a negative 4 minus 4 plus 2. All right. So we notice here that we have a half a cube roots of negative 8 plus 2. Bring the 2 over, so this will be negative 3 halves is equal to, the cube root of 8 is just a negative 2. And then I divide that and I get positive 3/4 is equal to a. So again, y equals 3/4 times the cube root of x minus 4 plus 2. And problem's done. Let's take a different tact on this now. We know that this function increases over this interval. So this is an x1 and this is an x2. We don't know what the y's are, but we know from negative 4 to negative 3, this graph is somehow rising. It's not necessarily a line, but we know it's going up. And then I take f of x and do this. I take and move all points to the left 5, down 10, and this is a y multiplier. All right, and I want to know, when will this increase? So, and I need an interval. So really all I'm looking for is two x values. I'm looking for a new x1 and x2 value. All right, which means I don't even need to consider myself with the y value unless, of course, there's a negative here which would flip this, which would mean anything that did increase is now going to decrease. So nothing to worry about there. All right, but this is the only thing I need to know. What happens to the x's? Because even if it moves down 10, way down here, it's still going to go up between those two x's. So all I need to do is say, well, hey, if I'm just backing all my x points up by negative 5, this new interval is from negative 9 to negative 8. And there's my answer. Okay? Now, this seems to be the same, but it's not. I know that there's a point, negative 4, negative 3 on the graph. So somewhere over here, don't know what the graph looks like, but over negative 4, negative 3, this is on the graph. It could be a parabola, it could be, I don't know, cube root, cubed, whatever. It could be a whole slew of things. But what I'm going to do is I'm going to transform it by backing up 5, going up 6, and an x multiplier of 3 in this case. So I want to know, where is this point going to be after I do all this? All right. Well, what you should do is actually go in reverse order of how you constructed your new graph. All right, so undo it that way. So usually we go left and right and then multiply. Well, to undo that and get back to this point, if you will, we're going to deconstruct it by doing the reverse order. So in this case, we're going to multiply first. All right, and that gets us a, let's do this, 3 times first. All right, and we're going to do that to the x value. So this goes to a negative 12, negative 3. And then, second, we're going to take and basically subtract, or add, sorry, 5 to the x. And then add 6. I lied over here. This was actually going to the right. Add 6 to the y. And if I do that, I'm at, what is that, negative 7 and 3. And that's where this point would go to. So again, instead of translating first and then multiplying, we multiply, then translate. Okay? And that's all we have for today. We'll see you next time.